Next, we will review problems from section 11.3. So, for these problems, we need to solve and then check for extraneous solutions if there are any. So let's take a look at problem number 9. We have the square root of 3x plus 10 equals 2. So, for this problem, I first want to subtract 10 to the other side. So I get the square root of 3x equals negative 8. Oh no, there is a negative on the other side of the equal to sign and a square root on this side. This automatically means that we have no solution. So on the test, be careful about that. If you see a square root with a negative on the other side, the answer is automatically no solution. Let's move on to number 10. So number 10, we have the square root of 2x minus 5 equals 9. So let's subtract 5. So we have the square root of 2x equals 4. Notice that we have a square root and we have a positive number on the other side. So this is okay. Now we want to get rid of the square root. So we're going to square both sides. And we get 2x equals 16. The last step is to divide by 2. So x equals 8. All right, moving on to the next problem, number 11. We have a square root on both sides of the equal sign. So we're going to square both sides to get rid of the square roots. So we have 5x minus 3 equals x plus 17. And I want to get both the x's on one side, so I'm going to subtract x and get 4x minus 3 equals 17. And then let's add 3 to the other side. So 4x equals 20. Divide by 4. So my final answer is x equals 5. All right, moving on to problem 12. Oh, problem 12 is a long one. So first thing that we want to do for problem 12 is subtract that 4 to the other side. So we have the square root of x plus 3 equals x minus 9. So this is not a negative on this side because of the x, so it's okay, we can keep going. So we're going to square both sides. But when I square x minus 9, I need to remember to put him in parentheses before I square him. And this is because when we do square him, we're going to need to write him twice in FOIL. So the square root of x plus 3 squared is just regular x plus 3. And let's write x minus 9 twice. And then we'll FOIL him out. So we get x plus 3 equals x squared minus 9x plus 81. So x plus 3 equals x squared minus 18x plus 81. And now I want to get everybody on one side and do some factoring. So if we subtract x and we subtract 3, we get, scooch over here, x squared minus 19x plus 78 equals 0. So now we need to factor. So we're going to make the big X, and we need to come up with two numbers that multiply to 78, but they add to negative 19. So this is the type of problem you would probably want to use your calculator for. So after trying a couple numbers, I found that 6 and 13 multiply to 78, and I'm going to make them both negative. So they still multiply to a positive 78, but they add to a negative 19. So I got two answers. I got x minus 6 and x minus 13 equals 0. We still need to take both of those factors and set them equal to 0 and then solve. So we get x equals 6 and x equals 13. Now we need to check and see if any of these solutions are extraneous. So let's scooch back over to our problem. And let's see, if I plug in a 6 back into the original, I get the square root of 9 plus 4, which is 7. Oh, sorry, the square root, yes, 7, equals 1. That doesn't seem right. If I plug in a 13, I get the square root of 16, which is 4. 4 plus 4 is 8. And if I plug a 13 in, 13 minus 5 is also 8. So it looks like 6 is an extraneous solution. Because when I plugged in 6, I got the square root of 9 plus 4 equals 6 minus 5. So 7 does not equal 1. So what we need to do is go back to x equals 6 and cross them out. Use a bad answer. And x equals 13 is the answer that we want. The next section we're going to review is section 11.4, which was all about Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. We definitely want to remember that formula. So number 13 says a right triangle has one leg that is 2 inches longer than the other leg. The length of the hypotenuse is the square root of 130 inches. Find the lengths of the legs. Okay, so let's draw a little triangle so we can see what's happening. And let's make sure we draw a right triangle. So here's my right triangle. And it's telling me that one leg is 2 inches longer than the other leg. So let's name this longer leg x plus 2 and this other leg x, since we don't know what their lengths are. We do know that the hypotenuse is the square root of 130. So now we can plug these values into our Pythagorean theorem and solve for x. So zoom in a little here so we have some room to work. So I'm going to plug x in for a squared. And for b squared, I'm going to use parentheses to plug in x plus 2. And then I'm going to plug in the square root of 130. But I need to remember to still square him, because the square root of 130 equals c, and then I want to square it. So we're going to get x squared, and then for x plus 2, remember we need to write him twice in FOIL. And then the square root of 130 squared is just a regular 130, since squares cancel out square roots. Okay, so now let's FOIL. So we get x squared plus 2x plus 2x plus 4. That still equals 130. So now, combining like terms, we get 2x squared plus 4x. And I'm going to subtract 130 to the other side so I can set everybody equal to 0. So that'll be minus 126. And then if I look at the numbers 2, 4, and 126, those are all divisible by 2. So I'm going to divide everybody by 2 so I can make the numbers a little smaller. So we have x squared plus 2x minus, let's see, what is 126 divided by 2? 63 equals 0. Okay, now it is time to factor. So let's make the big X. And we need to come up with two numbers that multiply to negative 63, but add to 2. So 63 is the same as 9 times 7. And in order to add to 2, we need to make the 7 negative. So we have the factors x plus 9 times x minus 7 equals 0. So now I need to take both of those factors and set them equal to 0. So I get x equals negative 9 and x equals positive 7. So now if we go back to our triangle, we still haven't answered the question yet, because the question is, what are the lengths of the legs? If I plug in a negative 9, I definitely have a problem, because I can't have a side that is negative in length. But I can plug in 7. And when I plug in 7, I get that this leg is 7 inches long, and then this leg would be 9 inches long. So the lengths of the legs are 7 and 9. Okay, let's talk about the last problem on this page. A right triangle has a hypotenuse that is 1 foot longer than leg B. The leg A equals 7. How long is leg B and the hypotenuse? So let's draw a picture of our triangle that we're working with here. So we know that there's a leg B, and the hypotenuse is 1 foot longer. So we'll call the hypotenuse B plus 1. And we know that leg A is 7, so we'll label the other leg as 7. And now we need to find the length of leg B and the length of the hypotenuse. So again, we'll use Pythagorean theorem. A squared plus B squared equals C squared. So for A, I'll plug in 7. For B, I'll just plug in B. But for C, I need to plug in B plus 1 in parentheses with a square. So you guessed it, I'm going to have to write B plus 1 twice in FOIL. But let's square 7 and get 49, and then we'll just leave that as B squared. And let's write B plus 1 twice. And then we'll FOIL him out. So we get B squared plus B plus 1. So 49 plus B squared equals B squared plus 2B plus 1. So I have a B squared here and a B squared here. So I'm going to subtract B squared to the other side. And when I do that, they just cancel out. So I'm left with 49 equals 2B plus 1. Oh, and this looks like a nice little equation to solve. So we'll subtract 1 and get 48 equals 2B divided by 2. So B equals 24. All right, so we know that this leg is 24 feet. And if we know that B is 24 feet, we know that the hypotenuse, B plus 1, has to be 25 feet.